A closed system is defined by there being no external forces on it. So the only forces are those being applied by objects inside of the system. And this comes with certain properties. For example, in a closed system, energy is always conserved. And this doesn't necessarily mean that specific types of energy are always conserved, but energy itself is always conserved. For example, if you have an object with being held up with gravitational potential energy and it's dropped, this energy will be converted into kinetic energy, but it will still be conserved, as in the amount of energy in the system will remain the same. Momentum is also always conserved in a closed system due to the conservation of momentum. So, and there are no external forces. So, it can be transferred from one object to another, and objects can have different velocities and masses within the system, but the momentum will be retained as long as there are no external forces acting on the system. So there's an example problem in the AP test where we can apply these rules. Problem 7. Two carts of equal mass are on a horizontal surface with negligible friction. Cart A is approaching cart B, which is at rest, as shown in figure 1 above. Attached to cart B is a spring that is initially compressed. At the moment cart A collides with cart B, the spring is released and pushes on cart A, shown in figure 2 above. Which of the following correctly states what happens to the kinetic energy and the momentum of the two-cart system as a result of the collision compared to those quantities before the collision? So I'll just show the diagram of what's going on. So this is figure A, and this cart B is at rest, and cart A is moving towards it, and the spring is compressed at this moment. And when they collide, the spring pushes outwards. So let's start with the energy. Let's consider what the energy was to begin with. So at the beginning of this problem, we had the kinetic energy of cart B, or excuse me, of cart A, and the potential energy of the spring because it's compressed. And in figure 2, all we have is the kinetic energy of cart A and the kinetic energy of cart B. We don't have any spring potential energy in figure 2 or any other sort of potential energy that we know about. So this means that the potential energy from figure 1 was converted into kinetic energy in figure 2. My pen cap fell off. And so this means that the kinetic energy has to increase. So as far as the momentum goes, momentum is conserved in a closed system, and this is a closed system because there aren't any external forces on it. There's the spring, but the spring is part of the system, so there are no external forces acting on these objects which would cause the momentum to increase. So the momentum remains the same, or the magnitude of the momentum. This doesn't necessarily mean that the momentum of one cart or the other changes, because cart B was initially at rest. So when it's at rest, the momentum is obviously 0, and then when it's moving, it's not going to be 0 anymore. But the magnitude of the system itself, the momentum of the system itself will remain the same.